I'm not sure I'm personally a big fan of making human beings live forever. That's not really my vision. To me, what the aspiration should be is to make humans spend a higher proportion of their lives feeling healthy and vibrant and functional. So some people refer to this as health span as opposed to extending lifespan. There are, of course, ideas of replacing body parts and ultimately replacing everything but the brain, but this raises the question of what is the concept of a human being and living. And it's possible in the future that we will adapt our concept of what a human being needs to be.
But we also haven't evolved to live forever. We've evolved to reproduce. So our bodies aren't optimized to live forever. If we wanted to live forever, we would have evolved in a very different way and probably not expend energy and have certain processes going on. It would be very different from how we are. I think what is feasible is to live maybe longer and certainly live more healthily. So I've continued to work on a problem which is the molecular basis of Alzheimer's disease, using similar methods to the ones that we use to develop the DNA sequencing. And so we've been trying to characterize the small aggregates that form on the way to forming the plaques and tangles in the brain to understand why they form and why they're toxic, with the idea ultimately of early diagnosis of the disease and developing treatments for Alzheimer's disease. The first thing we want to do with Alzheimer's is just be able to reduce the rate of decline in people so they can have a few more years where they can function fairly normally. And the big problem with the memory loss is we simply don't understand what causes that. So it's very difficult to design treatments until you understand what the cause is. And it's a very complex disease with multiple things contributing. So we've, compared to cancer, where we have multiple drugs that we can use, often in combination to treat the cancers, we don't know what goes wrong. We don't have drugs that intervene on these different pathways. We certainly don't have multiple drugs that we could use. So we've got a lot of work to do. But ultimately, I think we can solve this problem. We solved COVID very swiftly, operating in a global community. And I think, Alzheimer's is probably something that we could solve again if we all worked as a collective team, as a planet.
I've been working still on DNA. The sequencing that we did some time back, that was primarily to determine the genetic letters of DNA, which is genetic information. Now, genetic information is like the hardware that living systems have. But there are other ways of storing information in DNA, and this is a field called epigenetics. Now, epigenetic features in DNA, they keep changing. And they act like software. So they determine what machinery that the DNA codes for is switched on or switched off. These are the genes. So we have been studying ways to decode this dynamic epigenetic information and understand what that information tells us about living systems. So I'll give you some examples. Different cells in a human being all have the same genetic sequence, but the cells are very different. They are differentiated because the epigenetic software driving the genetic information is different in each cell type. So it relates to the function of cells and the identity of cells. So this is fundamental information. Now, where it's useful in applications is this information can reveal disease states. So one area is cancer early detection and diagnostics. There are now clinical trials being carried out by organizations whereby you take a blood sample. Now, some of the DNA from your cells leaks into the blood. And in diseases such as cancer, the cancer cells, many of them die and they release their contents into the bloodstream. So if you take a blood sample, isolate the DNA, which is fragments of DNA, there are now tests in development where you sequence the genetic information and also the epigenetic information from this DNA. And the early work suggests that it's possible to detect many different types of cancer early doing this sort of test. So the hope is at some point in the future, and I think this is probably 5 to 10 years away, as part of a routine blood test that may be annually, maybe more frequently than once a year, it'll be possible to pick up early signs of disease, even when people are asymptomatic and there are no other symptoms.
If the person hasn't got any symptoms for the disease, you could just stop the disease having any effect on their lives. That would be the vision that one would hope would happen.